Hello, Algebra 2. In our last video lesson, I had talked to you guys about squares and square roots. And so today we're going to work on the most popular application of squares and square roots, which is the Pythagorean theorem. So you guys have some experience with this from geometry, but I want to make sure we're really solid on it no matter how weird the roots in the problem are. So what the Pythagorean theorem says is that if you have a right triangle, that is to say, if you have a triangle where there's one right angle, you'll have two shorter sides. We typically call those the legs. And then you'll have one longer side, that's called the hypotenuse. And the hypotenuse is always the side directly across from the right angle. It's also always going to be the longest side in the right triangle. And so it turns out that for any right triangle, if you take the lengths of the two legs and you call those A and B, it does not matter which one A is and which one B is. They just need to be the two shorter sides as A and B. If you take A squared and add it to B squared, you'll get C squared, the length of the hypotenuse squared. And this works for any right triangle ever. So we're going to use this to find some missing sides today. So for instance, I gave you guys this triangle right here. I have a side of 6, I have a side of 8, and I don't know how long that longest side is. And so we're going to try to figure out the longest side. Here's what I'll say. It doesn't matter what A is, it doesn't matter what B is. What matters is that C is your hypotenuse. And so that means that whenever you have a right angle, you want to make sure that across from the right angle, that's the side that you call C. So the missing side in this triangle is side C, meaning I can call this side A and I can call this side B. But if you swapped which one was A and which one was B, it would still work. So I'm going to write down the Pythagorean theorem. A squared plus B squared equals C squared. So the length of side A is 6. So first I'm going to do 6 squared. The length of side B is 8. So I'm going to do 8 squared. And that is going to add up to the hypotenuse's length squared. So 6 squared is 36. 8 squared is 64. Those two add up to 100. So 100 is the length of side C squared. So C isn't 100, but whatever C is, if you square it, you'll get 100. And so a lot of these problems you'll be able to just do in your head. You can just be like, oh, 10 squared is 100. But technically speaking, what your brain is doing there is it's taking a square root. We talked about how squares and square roots are opposites. So if I want to get rid of a square, I use a square root. If I do the square root of C squared, those cancel, and I just get that C is equal to the square root of 100. The square root of 100 is 10. So the length of the missing side in this triangle, the length of the hypotenuse, has to be 10. And this would work no matter what the unit was. So if this was 6 inches and this is 8 inches, the hypotenuse would be 10 inches. Although if this was like 6 feet and this was 8 feet, this would be 10 feet, etc. And so like I said, you guys worked with some harder sort of squares and square roots last lesson. So those can come up in Pythagorean theorem problems also. So like in this triangle right here, I have a missing side. One side is equal to the square root of 33, which is like, I don't know, 5 point something. And then this side is equal to 7. So if I'm trying to find the missing side here, one thing to notice is that the missing side is a leg. The hypotenuse, C, is actually known. The thing that's missing is either A or B. So I'm going to call this side A, and I'm going to call this side B. Okay, Pythagorean theorem. A squared plus B squared equals C squared. So I do not know what A is. B is equal to the square root of 33 squared, and C is equal to 7 squared. Okay, so I don't know what A is. Here's the cool part. If you have the square root of 33, that's a weird number, but if I ask you to square it, we said last lesson, squares and square roots always cancel out. So the square root of 33 squared is just going to turn into 33. And then 7 squared is 49. Now for this problem, I have to do a little bit more algebra than the previous problem. I need to get A squared by itself first. So I'm going to subtract 33 from both sides so that I get that A squared all by itself is equal to 49 minus 33, which is 16. So A is the number that squares to 16. Again, you can probably do that in your head. You might be able to just be like, oh, 4 is the number that squares to 16. But technically, what your brain is doing is taking a square root. It's asking what squares to this number. The square root of a squared just gives me a. The square root of 16 is 4. The length of that side is 4. Okay, we are going to do a couple more problems, just messing around with some weirder roots. So I'm going to get rid of this. Basically, if you understood all the squaring of weird roots last time, you're in good shape with these problems. So for instance, let's say I said this was problem number 3. A right triangle with some missing side that I'm going to call x. A side right here that is a length of 5 times the square root of 2. And then this side right here is going to be the square root of 59. So like I said, we practiced with weird roots last time so that if you encounter weird roots, you'll know how to work with them. All right, so I know the Pythagorean theorem tells me that a squared plus b squared equals c squared. The one thing to be really careful about is what c is. How do I know what c is? It's across from the right angle. So in this triangle, the hypotenuse c is the square root of 59. And then I can call this side a, and I can call this side b. But if I mix those two, it still would work just fine. So I'm going to say that x squared plus 5 times the square root of 2 squared equals the square root of 59 squared. All right, so this is where you got to use all your squaring skills. X squared can just chill. 5 root 2 squared. This is like what we practiced on the last homework, where you have to square the front and you have to square the back. So this is going to take an extra step. I have to do 5 squared times the square root of 2 squared. Okay, so 5 squared makes 25. The square root of 2 squared, these two cancel, just gives me 2. So I have x squared plus 25 times 2. And then that's going to be equal to c squared. Just so we have enough space to totally see what's happening here, I'm going to write the blue part sort of by the triangle. So I had x squared, and then I had 5 root 2 squared, which became 5 squared times root 2 squared, 25 times 2. That total value is going to be 50. And then that's going to be equal to my c squared, square root of 59 squared. I know that square roots and squares just cancel out. That's 59. X squared plus 50 equals 59. And so the rest of this is easy. I need to do a little bit of algebra to get x squared by itself. So I'm going to do minus 50 minus 50. X squared all alone is going to be equal to 9. You can probably do that one in your head. What number squares to 9? Oh, that's 3. Technically, what your brain is doing is taking a square root. The square root of x squared, the square root and the square cancel out. You get that x is equal to the square root of 9, which is just 3. Lovely. All right, so one thing that'll sometimes happen, what I want you guys to be aware of, is that the answer to the problem, the missing side, is not always going to be a nice number, and I want you guys to be prepared for that. So, sometimes the missing side is a whole number value, but if it's not, here's how you'd proceed. So, for example, let's say I had this right triangle right here. I'm going to say that the hypotenuse is 12. I'm going to say that this leg is 10. And I'm going to say I do not know the identity of that side, x. So when I go to do my Pythagorean theorem, I can call this side a, this side b, this side c. If I do a squared plus b squared equals c squared, that's going to turn into x squared plus 10 squared is equal to 12 squared. Okay, so 10 squared is 100. 12 squared is 144. So when I go to get x by itself, I'm going to subtract 100 from both sides, and that's going to give me that x squared is equal to 144 minus 100, which is 44. So here's the thing. I do not know a whole number that squares to 44. I can't think of one. if I needed to solve this problem, it's definitely not just a whole number value. I mean, what I need to do is I need to take the square root of both sides. So the square root of x squared just turns to x, and I'm left with x being equal to the square root of 44. Just like when we saw the square root of 44 on our homework last time, we have two options. One option that's sort of a little bit more useful and practical is I might want an approximate, and that's where I would use my calculator. So if I take the square root of 44 on my calculator, you guys can probably see that's about 6.6. So if I'm rounding to the nearest tenth, I could say the approximate value of this is about 6.6. So I could say that side x is around 6.6 units long. The other option, just like on the homework, is you might be asked to simplify it. And that's where you would do your tree. So you could say that 44 is 4 times 11, which is 2 times 2 times 11. 2 on the inside makes 1 on the outside. I could say that this length is approximately 6.6. The exact value for it is 2 times the square root of 11. So that missing side I'm working with is approximately 6.6 units long. The exact length as a radical is 2 times the square root of 11. So you could be asked to do either or both of those for a Pythagorean theorem problem with a weird length. Okay, I'm going to erase this, show you guys just a little bit more. There's so many things that could happen with roots. I just want to make sure you're prepared for all the particular things that might come up. One of them is that your problem might not start off looking like a triangle. So for instance, you could get this shape right here, a rectangle. So a rectangle we know has a right angle in every single one of its corners. I could tell you, for instance, that a rectangle had one side that was 3 and one side that was 9. And you actually learned in geometry class that if the top is 9, the bottom is 9, if the left is 3, the right is 3, etc. A question I could ask you about this is, how long is the diagonal of this rectangle? How long is this diagonal? And it turns out that even though the original shape was not a right triangle, you can still use the Pythagorean theorem to figure this out, because half of a rectangle is a right triangle. That if I just redraw the top of this picture, I have this side that was 3, this side that was 9, here's my right angle. The diagonal, D, is the hypotenuse of the right triangle. So even if you do not start with a right triangle, you can still use the Pythagorean theorem if you can find a right triangle in the picture. So what I'm going to do is I'm going to say the hypotenuse right here is D. So I can say that 3 squared plus 9 squared is the diagonal squared. 9 plus 81 is the diagonal squared. So that means 90 is the diagonal squared. This is another instance where you're like, oh, I don't know anything that squares to 90. I can't really do that. Well, I do know that to get rid of a square, I take a square root. So the square root of d squared is d. D is equal to the square root of 90. And you've got two options. You can get the approximation for that root. Turns out that the square root of 90 is approximately 9.486, blah, blah, blah. So if I was going to round that to the nearest tenth, I would say that length is about 9.5 units. So that's my approximation. And I could also simplify it. So I could simplify it by making a tree. I've got 9 times 10, so that's 3 times 3 times 5 times 2. 2 on the inside makes 1 on the outside. Turns out that d is exactly equal to 3 times the square root of 10. So that's the exact radical length, that's the approximate length. Both of which are perfectly good. One last note, guys, just as a by the way, if you're doing a square root problem and you get kind of like a weird answer, like, let's say I finished things up and I'd gotten that x was equal to the square root of 35, and I tried to simplify that, and I was like, well, wait, it's only 7 and 5. I can't pull anything out. I can't simplify it. That's totally fine. Not every root will simplify, and that's okay. Sometimes things can get a little bit simpler. Sometimes things just have to sit where they are. So if you have a weird root and it won't simplify, don't panic. Just leave it the way it is. All right, good luck with assignment 2, everybody.